So I guess to reintroduce myself for folks who weren't at my previous session, my name's James. I'm based in New York City, and I've been working as a product manager in kind of the AI space generally for the past 4 or 5 years. Before that, also working as both a product manager and a software engineer on different B2B products. Um, as Bijan said, today we're going to be talking about recommendation systems, which is something that I worked on while I was at Meta. And this session is meant to be more of an interactive workshop where the goal is we're going to be kind of working together to build out a very basic, rudimentary, but functional recommendation system for music. So I'm going to be switching between a set of Google Slides and a Google Colab notebook. I put both of the links for those in the chat for the Zoom call, and hopefully we can make them available to the folks on LinkedIn as well. And with that, maybe I'll just jump in here. So let me share my screen. Cool. And I'm seeing it. Are folks able to see it? Are we good there? Cool.
Yep.
Great.
Yep.
Cool. So I already did my intro. We can just jump ahead here. So just going to talk a bit about what we're going to cover. So first, I'm going to do kind of a high-level introduction to recommendation systems, RecSys for short, and go over some definitions together just so we're all on the same page about what we'll be talking about in the workshop. The second section, which is going to be the bulk of this hour or so, is going to be the actual workshop where it's going to be a bit more interactive, talking about kind of the steps we would take if we were actually developing our own recommendation system. And even though this is going to be a bit more technical, a bit more code heavy, I'm hoping that we can also put on our PM hats and think through from a product perspective, what are some considerations we might want to take into account if we were actually being the PMs developing a kind of recommendation system ourselves. Third, after we kind of get through that workshop demo component, going to take some time to discuss, okay, if we actually, we're a resourced team or company trying to build out a recommendation system, we had more time than just this 1 hour to kind of throw something together. What are some things we might do? And again, kind of thinking a bit more critically from the PM perspective about that. And then lastly, just some final thoughts and hopefully more time for Q&A, depending on how much time we have left at the very end. So there are some prerequisites here. I'm not going to be going through how to code in Python. So I am assuming that anyone following along at least has a high-level understanding of how Python or similar object-oriented programming languages work. We're going to be using a pandas data frame to kind of move around most of the data that we're in. And I'm not really going to be going through what that is either, but it's a data structure that you can kind of use that has a lot of similar functions to SQL and Excel and some of those tools. So hopefully it'll make sense even if folks maybe haven't used one before. We'll also be using a Jupyter notebook, which is just kind of the file that we'll be running our code in, very common in the data science world. And I'm also assuming that folks have access to Google Colab, which is a free online tool that we'll be using to run this workshop. I don't think there are any real restrictions on Colab, so even if someone here hasn't used it before, should be pretty straightforward to get yourself onboarded if you just go to the website. Lastly, what we will not cover, so this is just going to be going over the recommendation system itself. We won't have time to actually develop any sort of UI for the recommendation system. So it's just going to be very basic, like run the code, see what the output is. We're not going to make it look that nice. Of course, if we were actually developing a product ourselves, that would be important and something we would consider, but not in scope for this talk. This is going to be kind of a rudimentary, pretty basic recommendation system where I'm playing around with it for the past few days and it works, but it's not going to be, world class within 1 hour. So, if this were the real world and we'd kind of built this thing out, we would of course spend additional time fine-tuning our model and our features and optimizing it and trying to make the output kind of as good as it can be. And we just won't have the time for that today. So that's out of scope. And then lastly, there's kind of the latest and greatest of what's going on in RecSys is kind of the use of LLMs within recommendation systems, both as a method to get user input as well as a way to kind of improve the recommendation systems themselves. Really interesting, and definitely recommend folks take time to read up on it if you're interested in that sort of thing, but not covered here today. Any questions before I dive into the intro? Cool. And feel free, I'm going to try to keep the Zoom window up. So if anyone has a question, feel free to raise your hand there, and I'll try to keep an eye on that and make sure to call on folks as they come up. So like I said, first, just going to do an introduction, get some definitions out of the way, and then hopefully we can spend the bulk of the time on the workshop itself. So firstly, what is a recommendation system? So kind of the formal definition is what I wrote here. It's a system, a subset of an information system that provides suggestions for items that are most pertinent to a particular user. What does that mean in the real world? Recommendation systems are actually present in almost every piece of software that we use these days. So I gave some kind of examples in the pictures here of course, TV streaming services. I'm sure we've all seen on something like Netflix, the section that's recommended for you, or similar things where, okay, Netflix has a catalog of thousands upon thousands of TV shows and movies, but for each individual user, they can only show a certain number of movies on their UI. Which ones do they show? How do they figure out what you as a user might be most likely to click upon? And that's kind of the whole point of the design of a recommendation system is you're optimizing around one metric that's important for your product. In the case of something like Netflix, it's probably optimizing for, okay, how many users are clicking and watching the titles that we're recommending to them in the top X number of titles. And you know your recommendation system is going to be successful if users are consistently at some level clicking and watching the movies, in the case of Netflix, that are being recommended in the recommendation system. So that's a pretty straightforward example, but there's a lot of less obvious ways that recommendation systems are used throughout tech today. So, I used to work at Facebook. Recommendation systems are all over the place there. And what I found surprising is kind of places they were used around like notifications, for example, or the ordering of tabs on the Facebook app. And there's nothing secret or proprietary about that. That's all public knowledge. So, when you open the Facebook app today, there's several options of tabs that can be displayed on the app. There's a set of probably 20, 25, 30 tabs that could be displayed, but they only have space in the UI for 4 or 5 of them. And so they have to decide, okay, for a particular user, what are the top couple tabs that we should put right there that are going to be most useful for that particular user? Would it be Facebook Marketplace? Would it be Facebook Dating? Would it be the Facebook Groups tab? Just a few of the options there that you kind of realize that the ability to rank and recommend things kind of appears all over the place. Generally, there's two major classes of ranking systems. So there's collaborative filtering, where the system takes in a user and generates a user taste profile for that user and recommends based on that. I gave the example of YouTube here. I don't have any secret sauce about YouTube, but just based on my own experience as a user, I definitely know that YouTube knows or thinks it knows that I like a few things, and it recommends videos based on what it thinks I like. And I'm sure we've all experienced that, where maybe if you watch a particular soccer team or basketball team, all of a sudden the system will start recommending you a ton of videos that are relevant to that soccer team or basketball team. Second type of system is called content-based filtering, and that starts with a seed piece of content and refines the recommendation based on user feedbacks. The example I gave here is Pandora Radio, where you start with a particular song or maybe genre. You pick a Taylor Swift song, for example, and then in the background will rank out of all of its songs that it has. Okay, well, what do we think is going to be most likely interesting to this user based on the Taylor Swift song that we gave them? And then it refines those rankings and recommendations based on explicit user feedback from there. Thumbs up or thumbs down. Did you like this song? and we'll go from there. So common issues that come with recommendation systems, I'm just going to talk about one here for the sake of time, is the cold start problem. So for both approaches, there's issues when there is a lack of data when the system is starting out on either approach. So for example, in collaborative filtering, where we're building out a user taste profile, if a user has just joined a system and the system doesn't have any information on that user, it becomes very difficult to recommend relevant, whatever maybe videos, songs to that user. Uh, and this can be problematic, particularly in the product world where, say users trying out your product for the first time, they've heard about your app, they think it might be interesting, they go onto the app, the recommendations engine starts, but it has no information on that new user. And so it just sends that user some stuff that may or may not be relevant to the user. And the user looks at that and is like, well, this isn't that good. And they leave and they don't come back. So solving the cold start problem is kind of continually an issue in recommendation systems today. A couple heuristics you can use to potentially attack it. You could just surface popular recommendations in the geo of the user. So, I'm based in the US. Maybe if I was a brand new user to say YouTube, for example, maybe they would show me just what are the 10, 20 most popular videos in the US right now. And that might be a good way to at least start off while it gathers information about me as a user. Um, or alternatively, you could also get some initial seed info from the user. I use the term interest picker here, but it could really be anything of like, you log on to the experience for the first time and it says, oh, well, what are you interested in? Do you like sports or do you like movies or do you like something else? And then, get a little more granular from there just to understand what this particular user might be interested in before actually serving them any recommendations. So, a note for this session, now that we've kind of talked a bit about the two major classes of recommendation systems, some problems with them. So for this session, we will not have any user preference data available to us, which is a good thing in my opinion, because of privacy concerns and whatnot. I don't think it's appropriate for us to, even if it was available publicly, to be using user preference data here. So we're not going to be attempting any collaborative-based approaches here. Instead, we're going to be focusing on a content-based approach. So again, starting with a seed, and then generating recommendations based on that seed, which, in the real world would also take in user feedback afterwards to refine that selection. Any questions on anything I've said before we start getting into the workshop component? Cool. Silence means I'm doing a good job. Great. So, first things first. So this is where, for those interested in trying to develop the system themselves with us and kind of following along, this is where we're going to be starting to do things. So, definitely pay attention. So as I mentioned, we're going to be using Google Colab in this session. So Google Colab is a free cloud service that lets users easily run and share Python code. And the main advantage is what it says there, without configuration or access to GPUs. So it doesn't really matter what machine you're using, or any kind of specific configurations on your machine. This will allow you to run code on the cloud for free, which is very nice. You can kind of think of it like a Google Docs system, but for Jupyter notebooks, where you can share them very easily, collaborate with other people. It's a nice system. I've created a notebook that I'll be referring to in this session, and I linked it here in the PowerPoint. Definitely feel free to click on it, follow along, or even make a copy yourself if you're interested. It's also linked in the Zoom chat there. So to do this, you can go to colab.research.google.com in your browser and create a new notebook. And so I've put some screenshots here on how to do that. You should see a screen that has a big blue new notebook option, or if that doesn't appear, just going to File, New Notebook is another way to do that. And once you've completed that step, which hopefully shouldn't take more than a minute or so here, you've now created a Jupyter notebook in Google Colab, which is exciting. Optionally, you can rename your file to something to help you find it later by clicking the title there, very similar to Google Docs, like I said. I'm just going to power forward here because hopefully that's pretty straightforward for folks. But if anyone's having an issue, please feel free to raise your hand. Let me know. I can slow this down. Second part of the setup that we'll be doing here is getting the data set. So this was actually kind of trickier than I thought it would be to find a data set that was going to be appropriate for this session. But we're going to be using a data set of about 27,000 songs. Actually, I should take a step back here. So what we will be doing is building a recommendation system specifically for recommending songs based on an input song. So, this is something I've developed myself and should be kind of fun. I found a data set online of 27,000 songs spanning from the years 1950 to 2019. That's publicly available under the CC BY 4.0 license. So we can use that. There's no issues from the licensing perspective there. The reason we'll be using this one is it doesn't require a login or anything. People can just go to the website. It's already formatted as a CSV, which will be very easy for us to use and small enough for you to download on your local device. Downside is that it's a bit older. So the last bit of data was from 2019, so 5 years old at this point. With 27,000 songs spanning almost 70 years, it's not comprehensive of all music, which limits the scope of our recommendations. So, we probably won't get the actual best recommendations across all music ever for every song, just because we don't have that in our data set. And then, as I mentioned earlier, there's no user preference data, so there's no data on ratings or specific user profiles or anything like that, which limits a little bit what we can do. So we're not going to be doing any sort of collaborative filtering. We're not going to be using user preferences at all, which I think is okay for this session, but just something to keep in mind that in the real world, you would want to take into account that information. So I've linked the website here in the slides. Let me also just put that in the Zoom chat. Here. Okay, so that should be available. And then what you should see when it's linked here is this research website. Definitely recommend taking a look at the author's paper as well. Definitely very interesting, and all credit goes to these folks here who put together the data set. You can just click on the file directly and download it here, or say download all, and both ways will get you the CSV on your local device. So make sure to get that data. Once you download it, you're going to have that on your local device. I do want to note that even if you've copied my Colab notebook and are just kind of following along, you will still have to download this data set and upload it to the notebook on your own instance in order for the Colab notebook to work. So data set, definitely a required step to this workshop. And again, please raise hands or chat if you're having trouble accessing that. I'll try to stop when I see something. The next step is, now that's downloaded on your local device, we're going to be going to our browser tab, and we're going to be running this code that's right here. So from google.colab, import files, and then uploaded equals files.upload. Pretty simple syntax there. Once you have that, you're going to click the play button, and it'll pop up that choose files button. And similar to many other websites that you've seen before, you'll be able to select the CSV that you just downloaded and upload it to Google Colab. So that's going to take a couple minutes to run just to upload all the data. But once you do, you'll have access to that file here, Google Colab. So for me, I ran that just earlier this morning, and it took about 3 minutes to run. So don't worry if it doesn't work right away. It might just take a second here. While that's hopefully happening in the background, we're also going to import some libraries. Most of these libraries are going to be pretty straightforward, ones that I'm sure you've seen before. The first one you're going to want to run while I'm talking here is this cell right here. So pip install sentence dash transformers. So I mentioned in the description for this talk that we're going to be working with some libraries from Hugging Face, and this is the main one that we're going to be using. It takes about a minute to download. So you just try to get that going as soon as you can once the file is uploaded as well. And again, these are all linked in the chat and everything. So are the slides going to be shared? Yep, they're already linked in the chat actually as well if you haven't found those. And as Bijan said, they'll be shared out after as well. The other libraries that we're going to be importing are pretty standard for these sorts of projects. So we'll be importing IO, which we'll be using to manipulate our CSV file here. We'll be importing pandas, which is the data manipulation library that I mentioned earlier. It kind of allows you to work with these files as you would in Excel or SQL. Has a lot of great functionality. We'll be importing NumPy and SciPy for calculation. So these are just great libraries that have a lot of built-in math and science functionality that we'll be using for some more machine learning stuff later on. Once the pip install sentence transformers library has been installed, you actually want to put that in your Python code as well. So from sentence transformers, which you got from that pip install, you'll want to import specifically these two pieces, sentence transformer and util, which we'll be using for looking at some sentence similarity later on as well. And then last but not least, we have some data visualization libraries coming in where we'll be taking PyPlot as well as Plotly, and we'll be using this for some of our exploratory data analysis in just a moment here. Cool. I see the notebook has been shared there. Great. So when you type this all out, a bunch of imports, just hit play, and then you'll get access to all of these libraries and all their functionality, which will make life much easier for the rest of this. The last step in this part of the setup is we're going to actually want to turn our input CSV into a pandas data frame. And that's this last line at the bottom of the screen here, where we're creating a variable, which I've called music, and we're taking pandas and we're reading in a CSV file, utilizing the IO library. So just copy this word for word and you should be fine. But basically what it's doing is taking in the CSV file that we had uploaded previously and making it available as a Python variable so that we can manipulate it in our Python code here.
Just to know if anybody has any questions or are people following. I can see some people, sorry to interrupt you, James, just want to quickly do a quick temperature check.
Yeah.
Oh, good. Looks like they are following, but if anybody is stuck somewhere, feel free to speak up now. Okay, going 1, 2, 3. All right, let's continue. Thank you.
Thank you. Great. So at this point, hopefully we have found our data set, uploaded it to our Colab notebook. It's now available as a variable for us to work with later in Python. And we've imported all the libraries that we'll need to use later on. Now we'll be getting into some of the actual work here. And so this is where it's going to become a bit more of a workshop and less of me hopefully talking at you. So the first step, as with any data science library project, before we dive into the actual model work, is looking at exploratory data analysis, or EDA for short. So, before you wanted to start picking models and playing around with things, it's important to understand the nature of the data you have to understand what appropriate choices are in terms of features for your model, what's the architecture of the model you want, that sort of thing. And so, just to kind of maybe speed through this a little bit, I think together we can look through maybe some of the high level stuff that I would want to look at first if I were starting out a project here. And then after we look at that high level stuff, we'll go into breakout sessions, folks can maybe discuss what they think would be useful, and we'll come back for a short discussion on EDA. So here, the first things I would want to look at, okay, what's the shape of the data set? How big is it? So, there's this code, music.shape. So now music refers to a pandas data frame that has all of our music data, all the song data that we took in. How much data do we have? So we can see here it's about 28,000 rows, 31 columns, which 28,000 to me feels big enough for the purposes of this project to do something good. It's not a small amount of data, but it's also not a massive, millions and millions of rows of data that you would probably need if you needed to build like a world-class recommendation engine. And okay, there are 31 columns. Well, what are those columns? So we can look at the different column names here. So artist name, track name, release date, genre, those seem pretty important, pretty relevant. Lyrics looks interesting to me. So we have the song lyrics. Len, I'm assuming, refers to the length of the song. And then we have some other variables here that are defined in that research paper, but basically when this data set was created, just trying to quantify certain aspects of the songs. And for me, if I were kind of jumping into this seems pretty interesting because here's some areas where we might have some numerical data that we can use to train our model a little bit better. So, how sad is the song? How energetic is it? How acoustic is it? How loud is it? These are things that seem pretty interesting that might help us do some of our predictions later. And so what does this look like? So there's a function in Pandas data frame called head, music.head, that just gives you the top 5 rows of the data frame, just so you can kind of see what sort of data is in there. And that helps you at a glance see, are there any issues? Is there any missing data? Or is some variable not exactly like you expected it to be? And just generally pretty useful there. So I'm looking at this and it's not quite going to fit on the screen. But we can see, okay, artist name, track name, release date, genre, all seem to make sense. Lyrics, it seems like we actually do have all the lyrics for the songs in there, the length of it. And then we can see that these numerical variables that we found are all floats, and it seems that they're all between 0 and 1. So they're already normalized, which is really nice. It skips over a few of them here, but I feel pretty confident that this is going to be the case. At the end, we have topic and age. So topic might just be talking about, okay, maybe what's the strongest one of these, it looks like. Age, I'm actually not entirely sure what that one means. So maybe we won't use those last two. So this is kind of the initial setup of the data. So what I'd like us to do together is now that we kind of know what the data looks like and the shape of the data set, I think it'd be great to think through in breakout groups. All right, well, if you were running this project, what are some things you would want to look at? Would you want to look at correlation of certain variables? Would you want to see if there's differences in a variable between certain times, certain genres, that sort of thing? Maybe we'll just do like a quick, like 2-minute discussion, and then we can come back as a larger group from there. Bijan, I don't know if you know how to do this actually.
Yeah, I can do that. So curious to know, should we do, I can do, I guess, five breakout, that's sufficient, right? Like 5 breakout rooms.
Yeah,
That
that
should be
seems
good.
good. We have 23 people, so that'll be
Sure.
about 4 per
Okay,
group.
cool. We'll get started. 1, 2, 3, and people will come back after 2 minutes. Thank you.
Cool.
All right, so I think the breakout is happening right now. Let me see if people are actually going to the rooms. Are people going to the rooms right now? Uh, yeah, okay,
I
perfect. So I
see
think
the
now
option.
people are able to go. Please start accepting, go to your rooms and start, and then we'll come back in 2 minutes.
Cool.
So I can see somebody just joined, so I'm just going to assign them to one of the rooms, and hopefully their teammates can explain to them what we're doing right now, right? So Okay, cool.
Cool.
We'll continue going. We're gonna give ourselves 2 more minutes. I can see.
I got the invite, but I'm gonna decline to break out
Yeah,
since
yeah,
I
you
don't think it
can.
would make sense for me to. Yeah,
Would be a too much of an advantage for one of the teams.
yeah,
Okay, perfect. So I can see some teams are formed and they're getting started, so that's okay. And
yeah.
all
So
right.
maybe we can bring folks back at like 10, or I'm on the East Coast, so I guess 10:06 or so.
Yeah,
Maybe another minute.
10:06. Got it. Okay, sure. Yeah.
Yeah,
Yeah.
just because I want to make sure we have enough time to get
Yeah.
through this. I wasn't sure kind of the timing of everything, so I think
Yeah.
it should be good to fit it within an hour, but maybe we'll spill over a little bit.
Yeah, that's fine. I think if we go over, that's totally okay.
Hmm.
So let me see. Are people actually in the rooms? Yeah, they are. I mean, most of them are, so that's good.
Hmm.
All right. So I'm gonna end the room now because it'll take 1 minute for everybody to come back. Right.
Sounds good.
Close the room. They'll be back in 60 seconds. All right. Countdown in progress. And for those of you on LinkedIn that would have liked to participate, please feel free to use the link to the Zoom to actually join the event. And in there, we've also shared the link to our community sessions Google Calendar, so you can actually enter your email address, get an invite, and start having a more active participation in some of the upcoming community sessions. We're going to have a lot of workshops in the weeks to come. So this is going to be pretty exciting for everybody. Okay, sounds good. Sorry to hear somebody's having an issue, not able to join, but we only have 3 seconds, so everybody's coming back pretty soon. So
Okay.
um, okay, cool. I think everybody is back. So passing back to you, James.
Cool. Yeah, looks like folks are trickling back in. Great. Well, thanks for humoring us with the breakout rooms, everyone. So I think maybe briefly we can just have a larger discussion for maybe 2 or 3 minutes on what was discussed. So maybe some prompt questions here would be, based on your discussion and what you've seen of the data set, what do we need to know about the data in order to properly choose and train a useful model? What insights, do you think we should go after first here? And then conversely, what is less likely to be useful for us to pursue? And spoiler, I've already done a little bit of the EDA in my notebook. So if you want to know what I think, you can just go to the notebook, but I'll be demoing that later as well. But for the purposes of this, would love just to have an open discussion about this for 2 or 3 minutes. And floor is open to anyone who wants to talk.
And one of the things that our group discussed is that there's no limit, correct, on the number of columns to select, correct?
Uh, you mean so there's 31 columns, but yeah, we could select all of them. There's no limitation there.
So off the top, we agreed on genre, seemed obvious, the artist name, the lyrics, and then there was a few others. I don't know if the rest of my team is on the call still.
Yeah, things like acoustics, sadness, and things like that, right? So certain people may be drawn towards it. So recommending based on the past choices and likes, it would make sense.
Sure. So just to maybe repeat what you guys said back to me to make sure I got it. So you're saying that it might be useful to examine what sort of data is in genre and artist name, and then secondarily, it sounded like acousticness, sadness, maybe seeing how that differs across genre. Is that fair to say? What you guys were saying?
Correct.
Cool. Yeah, I mean, those sound reasonable to me. I see in the chat we have someone who's asking about, what needs to be cleaned in the data. Are there multiple hits? That's definitely good information to look for as well. is there anything wrong with the data is definitely something we would want to check out. Null data, misconfigured data, things like that. Duplicative data, I assume, is what you mean by multiple hits, David. Definitely good to call that out as well. Artists with multiple hits. So in the chat, we have someone saying also artists with multiple hits. So yeah, maybe someone who has multiple, I'm assuming by hits we mean popular songs, maybe looking at some sort of popularity index if that were available to us. We also have, yeah, multiple hits versus one hit wonders. Yes, maybe the presence of artists in the database. That's actually a really good one. You know, in these 28,000 rows, is there someone who maybe has 100 rows in here versus someone who just has one? That might be something interesting to look at. Someone also mentioned most trending. So yeah, if we could look at, you know, if this data were maybe a bit more up to date, maybe we could look at, okay, who's on the rise right now? What's kind of a rising star, which certainly in recommendation systems, that's absolutely something we want to be aware of. And actually a very real issue that I didn't really talk about earlier, but a very real issue is, you know, sometimes systems have trouble surfacing new content or new artists, kind of a similar problem to the cold start where maybe there's no background on a particular artist or video, so the system doesn't know who to recommend it to or whether to recommend it at all. So kind of, you know, looking for rising stars and trending content is definitely important. A few other things in the chat here. So someone mentioned genre, topic, track name, trending, and mood. Those all seem very reasonable to look at. Checking for languages, definitely a good one as well. You know, my first language is English, so if a system is surfacing a non-English video to me, it might be less relevant than something that's in English. That's definitely a good one to call out. Someone else here said the duration that an artist has had hits for. So that's maybe like a relevance score. You know, how long has an artist been relevant? I guess kind of similar to that one hit wonder versus multiple hits idea of have they been around for a while or do they just have this one song? Might be interesting to look at that as well. Yeah. Conversely, I guess before I get back into the demo here, anyone have any ideas on what might be less useful to pursue? You know, something that maybe probably won't lead us to useful information. And it's okay if no one has anything too. Yeah, that's cool. I think, you know, for me, maybe less like useful information when I go back to the data set. So someone wrote length in the chat. I think that's definitely valid. Length probably is less of an indicator. I would think that for length, the only maybe indicator or strong signal would be if it was a very short or a very long song. So, you know, someone who typically listens to 3 minute long songs might not want a 2 hour long song, for example, if that even exists. And yeah, when I look at some of these, you know, not knowing exactly what all these variables mean, but just kind of going on what I've read about and what I think here, you know, this one that says violence, I'm not sure if that refers to like, you know, references to violence or things like that in the lyrics maybe, but that seems maybe a little less relevant to what we need here. Family slash gospel, you know, that might be relevant for certain songs, but I think across the corpus of our data, I'd imagine that probably the vast majority of it does not have, you know, kind of gospel family um, lyrics and things like that in there. So probably a little less relevant, I would think. Um, you know, some of these seem a bit duplicative, sadness and feelings. So, you know, if we were in the real world, we'd probably want to investigate kind of what specifically these variables mean. Someone called out track name. That's great. I think, you know, track name probably is not the most relevant for training our model. I would agree. It's important for displaying. We need to be able to display what the track name is, but in terms of actually training the model, the track name doesn't really give us any useful signal. Maybe a little bit. If it said something like it had the word country in it, then you might know it's a country song. But beyond that, probably not super useful. Cool. Well, thanks for that, guys. I'm gonna dive into this. So this is what I did. This is just my approach when I was kind of putting this together about what we could get done in this hour-long session. There's of course more you could do or different approaches you could take, but this is just my approach. So first, someone correctly called out that we would want to clean the data and just make sure there are no issues with it. So first, I checked to see if there were any null rows, any kind of missing information. We're fortunate here that in this case, with this data set, there's no null information. Doesn't seem we're really missing anything. I actually went ahead, I downloaded the data set and also had it open in Visual Studio Code here. And just kind of when I looked through as well, I was looking at Zach Brown earlier. When I looked through as well, it didn't really seem, you can kind of see here, like any data was missing. So that's good. And that kind of makes sense. We're using a research data set. They probably cleaned it themselves. So thanks to those researchers for taking care of that for us. But if this were in the real world, we probably would have some missing or misconfigured data that we would have to fix. So we won't have to do any fixing here, but just something to keep in mind in the future. Things that I looked at, I was interested in just kind of looking at the shape of the data across time. So, we know that the data is from 1950 to 2019, but is it uniform? Is it relatively flat? It turns out the answer is no. So we can see here that we have a lot more data kind of from 1980 or so onwards. While as before 1980, it's definitely a much smaller data set, and particularly in the 1950s, early 1950s here, there's not really much data on the music there. So what that tells me is for this particular data set, it's probably going to perform better for songs that are from 1980 onwards than it will for songs earlier in the data set, particularly in the early 1950s. So I think, for our purposes, this kind of rudimentary data set, we can probably expect that it won't perform super well on a song from 1952, but it might perform better for a song from like 2012. So that's something to think about. I also was curious about, what's the breakdown of the genres here. And so again, I'm kind of skimming over the code, but, all of these are just looking at the different variables and then using PyPlot and some of these other tools to visualize it so we can look at it together. Definitely feel free to copy what I have from the link. And we can see here that, okay, well, it seems that most of the genres are pretty well represented, but we can see that hip hop is pretty underrepresented in the data set. So it only has 3% of the data set. So 900 songs out of 28,000, that's pretty small. Reggae also a bit on the smaller side, about 2,400 out of 28,000. So for me, that says particularly hip hop, we probably won't be very predictive on. Well as these larger groups, pop, country, blues, rock, we'll probably do better on. And I think like anecdotally from what I know of music, that makes sense. Hip hop only became bigger in kind of like the 80s and 90s onwards. So there's probably just less data available of hip hop than some of these other genres if we're going from the 1950s to 2019. So it makes sense, but it just tells us that it might not be as predictive. So we can kind of say that, okay, well, it seems that newer music that falls into pop, country, rock, those sorts of genres, we're probably going to be doing better with that than older music and then genres like hip hop and reggae. And so then, looking at some of this information, I was kind of interested in looking at some of these normalized variables that the researchers had put together. What do these look like across years? Is there a difference in some of these variables from earlier years to later years and so on? And so I've actually plotted this out just for us to take a look. So I just picked a couple variables that seemed interesting to me. So danceability, to me, like one that might change over time, loudness, acousticness, and energy. Surprisingly, so there is a slight change in danceability and loudness over time, where both increase over time. I think that makes sense. Pop music has gone more electronic, more dancey, I guess you could call it. It makes sense there be an increase, but it's not as big of an increase as I would have thought. And I removed the axes here for clarity, but you can always put the axes back and see the exact numerical difference. But you can tell just from the shape that it's not a huge difference. While as acousticness and energy, it's more of a drastic difference here, where the acousticness of music has gone way down, the energy has gone way up. That makes sense to me anecdotally, where, in the 50s and so on, there wasn't really much um, non-acoustic music. There wasn't really much electric. So it should be near 100% acoustic. And as time goes on, we come to rely on electric instruments and now synthesizers and those sorts of things. It would go down. And same with energy, just like, as things have gone more electronic and synthy, it makes sense that energy would go up. So those might be two interesting variables for us to look at, where it might be more predictive of, okay, if I choose a song as input from the 1990s, it'll probably be lower on the acoustic side, higher on the energy side. It might be more predictive for what would be a good recommendation. I see there's a question about how the data was originally labeled. I'm actually just using the exact variable names from the original data set, so I haven't changed any of the names here. The paper on that research website better explains what the researchers meant with each of these variable names, but you can kind of get a sense just from looking at it what they intended. Cool. I also took a look at these 4 variables to see if there were differences across genre as well. Not as predictive as I was hoping. So danceability and loudness, not a whole lot of difference between the two. Reggae and rock seem to be a little bit higher on the danceability scale, which I thought was interesting. I would have thought pop, but I guess pop is also a very broad umbrella, which might include, slower songs, sadder songs. So I guess that makes sense. Acousticness and energy. So acousticness is a bit misleading here, where we can see that actually from the scale, all of these are below 0.5. So acousticness is actually pretty low across the board, and these differences aren't as big as you would think. I should have probably taken the time to normalize the y-axis, but I didn't. So actually, this is more flat than you would think on the acousticness. And on the energy side, kind of correlated with loudness, reggae and rock are a bit higher up. Hip hop, jazz, pop are kind of in the middle. Blues and country are a bit lower. Makes sense to me. That's just some ideas, I kind of have there of things you could potentially look at. There's of course a whole world of variables you can look at. How are they correlated? How are things working there? So that was the demo. From the EDA, we're going to move into model choice. And I know we're running a bit low on time, so I'm going to rush through this, but just to tell people, we'll probably be a bit longer than an hour at this rate. So, hopefully you can stay past the 1 hour mark with us as we kind of wrap up this workshop. So in the real world, based on the data set and your use case and your product and the EDA you've done, there's a variety of model choices and architectures that you could look at. In the real world, we would take a lot more time and thought to put into this to think through, okay, well, what do we think is going to be really the best model? And maybe we test them out a bit just to see what has the best performance when looking at different metrics that are important to us. For the purposes of this 1 hour workshop, we're just going to leverage the data available to us to make some high confidence guesses on how we want to design this thing. So I think similar to what we did for EDA, it'd be great if we could maybe break out for 2 minutes or so, have a discussion on what we think might be useful model choice, but also useful to train the model on. So, based on the variables we've seen, what's just going to be the most useful approach here. And then we can have a quick discussion, and then I'll get into what I ended up deciding to do, and we can walk through that together. So Bijan, I guess if you don't mind, helping me
Sure.
set the breakouts again, that'd be
All
great.
right, the breakout's gonna start. So like we said, 2 minutes. There you go.
Cool.
All right, so it's at 24. I guess we can kind of start the countdown at 26. And
Yeah, that
I
seems
can see
right.
people are starting to join into different rooms, so okay, perfect.
Yeah, I'm guessing this will probably be maybe 15 minutes over, so based on the
Yeah,
pace
that's
we've been
okay.
going.
That's fine. It looks
Okay.
like people are enjoying the session, so that's important.
Yeah, me too. It was fun
Yeah,
to put this together.
yeah. Thank you for doing that. That's great. I think people are finding it helpful. I already got somebody messaging me saying that they're enjoying it. So that's,
Oh, great.
yeah.
That's great to hear.
Yep. All right. So let me see if anybody has any issues. No, I mean, everybody is pretty good. Room one is active. Room two is active. Yeah. All these different rooms are active. One of the rooms is not, but that's okay. All right. So still not 26 yet. All right, and for those of you that are on LinkedIn, like I said earlier, if you decide that this is something that you're enjoying and you like to be part of the workshop, um, feel free to join the Zoom link that we've provided, and here you'll be able to actually participate in these workshops in the future, and we'll be sending you Google Calendar invites as well. Okay, perfect. I'm gonna end the room, and the 1 minute countdown is gonna start now.
Cool.
So people will be back in about 50 seconds. All right. All right, 30 seconds left. All right, so 1 second and everybody's back. Okay, back to you, James.
Cool. Great. So similar to what we did for the EDA, just gonna have a quick like 2 or 3 minute discussion together, and afterwards I'll go through what I did personally. And if you want to jump ahead and look at my notebook, you're of course welcome to do so. But yeah, it's just maybe some first questions to kick things off. So based on the EDA we did and some of the EDA we came up with in our discussion, what seems like a good model choice? What seems like maybe good features to focus on? Uh, are there any limitations that maybe rule out certain models? And should we train our model more heavily on some data than on other data? I'd love to hear folks' thoughts on that, and the floor is open.
All right, if anybody want to share your thoughts, please unmute yourself. Go ahead, Kira.
Yeah, group four. We were just discussing that, like you said, James, acoustics and energy seems to be the distinct ones, along with genre. If we can see and recommend what is similar, then somebody who likes lower acoustics, sorry, not acoustics, yeah, higher acoustics, lower energy, could be somebody who likes blues. It may also spill into uh, pop, slow pop, but still, I think it would fit into their like the probability of them liking it may be high. So if those two are the features, it kind of made sense when we were discussing it.
Yeah, thanks for sharing that. That makes sense to me based on what we saw. Those seem to be better predictors. and across years and across genres. So that might be a good one to look at. Yeah. I see in the chat we have someone talking about popular artists versus niche artists. So again, maybe could we train the model on something like artist count? If we're assuming our data set is about, maybe if this were like the Billboard 100 data set, if someone's showing up more frequently, that probably says they're more popular. That could be interesting to look at and train the model on. We also in the chat have lyrics similarity between songs. I think that's definitely a great one to look at. So, if I like a certain song that's maybe about, I don't know, maybe I'm listening to a love song, and you might want to look at the lyrics to see if other songs are about love or a similar topic. That definitely might be a good one to look at. Cool. Any other thoughts before I demo what I ended up going with? Cool. And apologies, I know this was meant to be a 1 hour session and we're a bit over. Oops. That should be okay. Unfortunately, my session just disconnected. That should be all right. Let's get back down to where we were. I created a couple different methods on just things that I thought might be interesting if we were developing this model. Want to emphasize this is very rudimentary. This is not a world-class recommendation engine or anything like that, in part because the limitations on the data, and in part because we haven't really taken the time to really optimize for some of these features specifically. And one limitation that I had on the methods I came up with here is our seed songs have to be in the data set already. So the model has to already know about a certain song before it can give recommendations of the other songs. In the real world, we would try to make this more robust, where we could take in more resilient user input of maybe songs that aren't in the data set or misspellings or things like that. But just for the purposes of this workshop, we have that limitation in the code I've written here. In terms of features, so I definitely agree with what I think it was Kieran and some others were saying, where some of these variables are probably going to be more predictive than others. Just for completeness, I decided to kind of take all of those 0 to 1 floats and put them in an array and use that to see if it could be predictive of good recommendations here. So in terms of the code, here we have the features kind of written out here, so the different column names. And I've added a lot of comments to hopefully explain the code, but basically we're going to find the seed songs information in our data set, and we're going to calculate what we call the Euclidean distance between the input features in each row of the database. So that's just a fancy way of saying how similar are our input songs features to the features of all the other songs in the data set. We can then sort that similarity index. So we've now created a similarity score, basically, between our input song and all the other songs in our data set. And then we can sort it to find, okay, well, which are the most similar based on this calculation that we've done. And all that this code is doing is basically just that, just create the similarity score, sort it, and take the top X and print that out. In this case, I hard coded in that we were going to just do 10. You don't have to limit yourself to 10. Here's the number right there. You could have that be any number, or you could not limit it. I just felt like for displaying it here, it was easier just to do 10. So I had a test one. I picked Learn to Fly by the Foo Fighters. We can see that looking at those similarity scores, okay, so we got, this is a rock song from 1999. We got a lot of rock songs that came here from like the 2000s, 90s. We have one country song that seems to be a bit of an outlier, but maybe it's in a style that's similar to that kind of music. But largely this seems, from what I know of the songs that are on here, like a pretty good recommendation set. Similar sort of music here. If we want to try something a bit different, here I pulled out a couple names from the data set ahead of time just to make it easier to go through this. Pocketful of Sunshine was a pop song in the 2000s. If we look at the results here, seems like a good number of pop, mostly from the 2000s. Some music from the 80s sprinkled in, so that might be interesting to look at. You know, are there similarities between kind of the style of music there? The third one, just to kind of, for completeness, get a different kind of song here. We have a country song from the 2010s. And we can see here, okay, a mix of country, pop, that kind of makes sense. I feel like the line can be a bit blurred sometimes between the two, mostly from the 2010s, a couple of older songs sprinkled in here. From what I know of each of these songs, these seem like pretty good recommendations. And again, if we were kind of doing this in the real world, we would, of course, optimize and make it a bit more robust. But this seems right to me. So that's method one. Any questions on that before I jump into the second method? So we have a question around why we chose Euclidean distance over other similarity method measures. That's a great question. I think this is where I'd say in the real world, we would probably test like several different similarity metrics to see which is the most appropriate for music. For me, just as I was developing this demo, I chose Euclidean simply because it's the most common and generally gets good results kind of across the board when you're looking at distance. And so if you look at, you know, examples online for recommendation systems, movies and all sorts of other different areas, generally people use Euclidean as a starting point because it's, I won't go as far as to call it the standard, but it's just kind of a good starting point for most folks. And the results seem to be good enough here that I just kind of said, you know, this is fine for the demo. But yeah, in the real world, definitely would encourage you to look at other distance, similarity metrics. Any other questions? Cool. So I know we're a bit over time, so I'll just kind of jump into the second one. I'm not going to run this code because it takes about half an hour to run. So if you're following along on your own computer, just you've been warned, this takes a while to run. But this is where we get into using a model from Hugging Face. So someone earlier in the chat had suggested if we looked at the similarity between lyrics, and that's actually exactly what we're going to be doing here. So we're going to be taking the sentence transformer class from Hugging Face, and we're going to be creating embeddings on the lyrics for each song. This takes a while to run, excuse me, because there's 28,000 rows, and the lyrics are a larger data set or a larger set of data within the data set. So it just takes a longer amount of time to kind of encode all of those. We use cosine. We then use cosine similarity, so a different similarity measure to address what someone was asking about earlier, to look at the similarity between all possible pairs within our data set. And so this gives us a very robust matrix of similarity measures between every song and every other song based on the similarity of lyrics in the data set. And from there, we can just basically look up, okay, well, what are the most similar songs for our input song and kind of rank them from there. So this is the method. Like I said, we've already trained our sentence transformer and have created this matrix of embeddings, comparing all of the songs to all the other songs. And then in this recommendation, we are scoring our input song against the other songs and just finding what are the most similar songs here based on lyrics. And so if we run this, which I did, I just used the same input song for consistency. So Learn to Fly, you know, by the Foo Fighters. Okay, it's a song from '99. We can see that a lot of rock, country, mostly from the 2010s is coming up. That seems appropriate to me from what I know of the song, and kind of it was a little bit ahead of its time. And the genre seems appropriate here. So these seem like pretty decent recommendations. Again, if we go through some of our other examples here, Risking with a live demo, kind kind of similar. Okay, so Pocket Full of Sunshine gets us again pop music from the 2000s and 90s. Um, Pretty decent recommendations. This probably would be an okay playlist if you were doing this in the real world. And then we have that same song. I'm just using the same three for consistency so we could see the similarities and differences between the different approaches. This is a country song from the 2010s. We can see this one's a bit more all over the place. So we do have a lot of blues and country, which is good, but in terms of the year, that kind of switches around a lot. So to me, that tells me that, comparing lyrics, it's good to a degree. It seems like we're in the right realm, but maybe a little less accurate than looking at some of the features that have been pulled out in the data set. So lyrics alone probably are not good enough to get us kind of where we need to go in terms of a recommendation set. So like good, but could be better. So with that in mind, the third technique is just simply combining the two that we did before. This will be the final technique. And this is pretty common in the data science world for those of you who work with data scientists, and machine learning engineers. Oftentimes some of the best methods just to stack a few models together and see kind of what the aggregation of the output is to get the best score. And so all this method does, it does exactly what the first two ones did. The only thing I would call out is what we do here is we actually multiply the two scores from the two different models together. I think that's an appropriate choice here because we know that our output similarity scores are going to be between 0 and 1. So by multiplying the two together, we're remaining between 0 and 1, and we can rank them appropriately from there. If your own scoring was different, then you might want to look at maybe doing an average or some other method. But for me, multiplication felt fine for this choice. And so then if we run it, again, just kind of equal weighting of the two scores. Another thing I'll call out is you would want to potentially weight the output of the two different models based on what you felt was a stronger predictor versus a less strong predictor. So as we saw, it seemed that using the features was a stronger predictor than using the lyrics. So maybe in the real world, we would want to weight the feature output more than the lyric output. But for now, we've just weighted them equally for the sake of this. And if we do the final recommendation, this to me feels like probably the best set of recommendations we've had so far, where, okay, we're inputting a song from almost 2000 and we're getting a lot of pop and rock from like 2000s, early 2010s. I know most of these songs, and this feels like a pretty good recommendation set from what we've seen. Again, keeping in mind that our data set is kind of limited as well. And if we look at maybe some of the other examples that we had just to compare for the sake of completeness, okay, this one we got pretty much all pop music from the right era. So 90s through like early 2010s. That seems appropriate for a pop song from 2008. That came out pretty well. And I know most of this music too. That seems right. And then lastly, that country song, again, continuing with our live demo. And here we have a lot of country music and pop music from the 2010s, late 2000s. I don't know this music as well, I'll be honest, but at least looking at the data that's here, this seems right for what we know. Yeah, those are the three methods that I chose. So switching back to our presentation here, we're almost done. So maybe we can do like a quick discussion. I guess my ideas are kind of already on here, but what I was hoping to do in this section is, let's take a chance to put on our PM hat. So we've developed a rudimentary recommendation system, but if you were the PM running this and you had to make it better or more useful for your users, I was curious what folks thought that they might do to make this better. And I've spoiled my own ideas. Feel free to copy those if you want, or if you have something else you want to say, feel free to do that as well. But floor is open. Okay, and if there's not, I can just quickly go through mine since I know we're a bit over time here. So for me, the most critical piece we would need to add in is to allow for user feedback to give positive or negative feedback to the system so that the system can optimize and tweak itself from there. That's kind of one of the crux of the content-based filtering systems that we discussed at the very beginning of this talk, where, okay, we're using a piece of seed content, we're creating recommendations based on it, but we still need that user input of like, this is good or this is bad, to tweak from there. So that's probably the first thing that I would want to address. Some of the other ideas are actually similar to what folks in the discussion had earlier discussions had said. So I didn't really make direct use of dimensions like genre or release date. I more used those as kind of sanity checks on the output to see if it looked right. But I think in the real world, you would probably want to lean more heavily on something like genre, where, okay, if someone's listening to a rock song, well, probably serve them mostly rock songs, the recommendations, and look at that a bit more heavily. Already discussed that there's some limitations of how we're taking user inputs. In the real world, we'd want to make that a lot more robust. Um, in a real system, we would probably also be able to gather user preference data and kind of have a more collaborative filtering based system. We didn't have that data available, but in the real world, you might want to look at that. Having more up-to-date data. This data is 5 years old, so getting music from the 2020s would probably be useful. Looking at maybe even more nuanced data dimensions. Are there other kind of pieces of information we could pull out from the songs that might be better predictors than what we have? Building out a front end for users, of course, that was out of scope for this talk. We said that at the beginning, but in the real world, you'd want to kind of develop a better user input system than just a Jupyter notebook here. And then a more advanced architecture. We didn't really touch on this, but a lot of recommendation systems these days are neural net based architectures, where you train a neural net of some architecture that you've decided with a bunch of data, and then it creates weights for its different vertices, and you're able to kind of feed in input data, get out output data, it can self-correct from there. Neural net architectures perform better, but are very hard to explain. That you can't really understand necessarily how the neural net got to its decision. So for the purposes of this class, I avoided neural nets. They also take a bit longer to train typically, so it just didn't seem like the right choice for this session. But in the real world, you might want to explore looking at a neural net based architecture. Cool. So final thoughts. So we spent a lot of time earlier today focusing on the data set in EDA. And I think, that should be a key takeaway here, where a lot of people, especially if they're kind of getting started in the machine learning space, they're very excited. They want to jump straight into the models, start doing things with, excuse me, neural nets and reinforcement learning and all sorts of things. But in reality, this is a data science-based field, and understanding your data is going to be the most important thing before you make any decisions around your model architecture, and actually start training and giving outputs and things. So, if we hadn't looked at our data, then we might not realize that, oh, okay, we're not going to be able to predict music from the 1950s as well as music from the 2010s, and we're not going to be able to predict hip hop as well as we can predict rock. And so understanding kind of what is available to you, the shape of the data, the information there is critical when it comes to training the model. Secondly, it's fun and encouraging that we can spin up a rudimentary recommendation system like this in just a few hours. It's very exciting that this technology is available to us, and I definitely hope folks play around with it on their own. But of course, as I mentioned, there were a lot of kind of simplifying assumptions we made, and we made just a lot smaller and less robust than a real world system would be. And so to actually develop like a world-class recommendation system that's robust, resilient, can handle all these problems that we mentioned, it's going to take a bit longer and to develop. And what's kind of exciting is this is still an evolving field of research where, even today, there's just more being discovered all the time on what is the best way to recommend things to people, and how do we address some of these issues like the cold start problem that we talked about earlier. And lastly, like I mentioned earlier, recommendation systems are appearing everywhere in our online lives, whether it's through advertisements or videos, music, notifications. Pretty much everything you touch is going to have some sort of ranking system somewhere in there. And so I've definitely encouraged folks who listen to this session to look a little more critically at the websites and apps you're using, see if you can figure out where some of these ranking systems might be present and how they might be deciding on how to rank things. What kind of inputs might you be giving that it's using to then rank things on the back end? It's kind of interesting to think about. I linked a bunch of references and articles for further reading. The references section are ones that I use for inspiration for this talk, as well as the data set, giving credit to the data set and the researchers who put that together. There's also a few articles if you want to kind of get into more advanced topics, the recommendation systems and Hugging Face that might be interesting. If you really want to dive in, so I know we shouldn't recommend Wikipedia, but Wikipedia actually does have a very robust set of articles on the topic of recommendation systems and how they all work that are in a pretty relatively easy to understand way. So I would definitely recommend looking at the set of articles there as a starting point, just to kind of get a background on it. Also, the Rexis conference each year, which is run by ACM, is kind of the premier recommendation systems conference. And they have a ton of public talks, papers, things you can look at if you want to understand what's the most cutting edge thing happening in recommendation systems right now. A ton of great resources there, and definitely recommend taking a look. So with that, just want to say thank you to everyone for listening. And I know we're way over, but I can stick around for a few minutes for Q&A. If folks have any questions, feel free to connect with me also on LinkedIn, or my email is right there as well. Yeah, just wanted to say, and thanks to Bijan and Product Management Exercises for having me on today.
Awesome. Thank you so much, James. Really appreciate you putting together this great workshop. And I hope people enjoyed it as well. I got a couple questions from people asking me if the slides will be available. Yes, the slides will be available. And somebody who is in the May cohort is asking, anyway, we can get the slides for different community sessions. Yes, so they'll become available next week. We're actually releasing the new community session webpage. It's a new version of it next week. You will be able to access previous sessions, upcoming sessions, all that stuff. So hopefully you guys find that helpful. For those of you that are in the chat and you're considering our AIPM cohort, I highly recommend you to apply. It's really the best program out there if you're thinking about breaking into AI product management. So feel free to check it out. You get to build a product. You'll actually going to be very hands-on, and we have a 7-day refund policy. So in case you decide after 7 days of participating that this is not the right program, no questions asked, you can do a refund. Thank you so much, James, again for coming in. I thought this was a really amazing session. Hopefully people enjoyed it. Thank you for the positive notes, everybody. So when the session is over, you guys will be facing a kind of a quick survey on what you thought about the session. I asked people on Zoom to participate. Your feedback will be really helpful for us, and we greatly appreciate it. Thank you so much again, and please have a great weekend ahead of yourself. Take care, James. Bye.
Right. Thanks, everyone.
The AI course at Product Management Exercises has been wonderful for my career. It set a great foundation to fully understand AI and the AI space that I can directly implement into my day-to-day work to really make an impact in what I'm working on for my users and for my career moving forward. So I highly recommend this to anyone that's looking for the foundation they need to be successful in the AI space.